Very good day to Dr. Zahir. We are from Group 6. My name is Ong Hui Ling and my matrix number is 198876 and my group member consists of Emilia, Elyasa, matrix number 198458, No Ariena Harnis, matrix number 198743 and Nasser Khaled, matrix number 195600. Next, I will present on the introduction. Water is most necessary for sustaining life and increasing the quality of life. However, it can transmit disease as well. When there is a poor access to clean and safe water, waterborne disease become widespread. Contaminated or unsafe drinking water has become one of the major factors of diarrheal disease, which are known to be the leading cause of death globally, especially in children aged below 5. According to Center for Disease Control and Prevention (CDC), diarrhea kills 2,195 children every day, even more than AIDS, malaria, and measles combined. Next, I will present on the problem statement. A survey conducted by Nigeria Bureau of Statistics shows that millions of households in Nigeria lack access to improved and safe drinking water supply. This has resulted in high incidence of diarrhea-related morbidity and mortalities in that country. According to UNICEF and WHO, the use of contaminated drinking water leads to death of more than 70,000 children under 5 annually. Only 26.5% of Nigerian populations use improved drinking water sources and sanitation facilities. So next, I will present on the objective. The objective of this project are to design a simple and low-cost filter press unit which is capable of treating contaminated water in order to render it safe to drink. To build and construct a ceramic water filter press using locally sourced material and manpower in order to reduce the cost of constructions and promote the affordability of this model. To ensure a continuous and sustainable access to clean and safe water supply in Nigeria.
Now I will proceed with the ideas of the experiment that we propose. So these are the diagram of a filter press, which consists of head soap, male filter mold, female filter mold, head slide, 20-ton hydraulic jack, stand, leg, new frame, and lifter. And then these are material for the mold, which is aluminium, 2-inch plywood, sand, metal spoon, rotary furnace, furnace saw, carrier root, and metal wood. And the material for the frame is cast iron, steel, drillers, nuts and bolts, hydraulic jack, hydraulic control box, and spring. These are the method of preparing the mold. However, I'll explain to you guys using this diagram. So, the first step is create a wooden pattern which held together with a resin bond by cut off the pieces of 2-inch plywood following the designated mold cast, and then fill up firmly a square wooden frame in which the wooden pattern has been placed in a fine sand. Take the wooden pattern out from the sand mold and smother the sand using a metal spoon. And the fourth one is charge pieces of aluminium into a rotary furnace and melt the metal with a temperature of 600 to 700 degrees C. And then take the molten aluminium out from the furnace using a pair of furnace tongs and pour the molten melt into the sand mold while poking at it using a rod to remove the bubbles. And this is the last one, which is cool the metal cast for 24 hours before removing it from the mold and polish the surface of the cast to the aluminium after inside. These are the preparations of the frame, and I will also explain it through this diagram. The first step is cut the long metal into dimension and drill holes through them to enable the assembly of frame using a rope, nuts, and bolts. And then bolt the metal component of the mold onto metal sticks, which welded to the headstock of the frame, and female component was fitted into the movable headlight. And then fix the lever system, which is used to control the lifting of the headlight, bearing the female mold during the pressing and release of the mold in the plate. And then install a hydraulic jack and set in operation with the lever. And the fifth one is install the hydraulic control box and connect to the jack. And the last one is spray the entire frame with paint to improve the aesthetic and to prevent rusting.
Now, let's look at the video that we have prepared and the steps to build the press filtration model.
So now I will explain a bit about the costing. To make the hydraulic press filter, the table below shows the material quantity, price, and total price that is needed. Total price is counted by time price, multiple price with the quantity. As you can see, for aluminium, we need 10 kg aluminium. We need one unit 2-inch plywood, 10 kg fine sands, one piece metal spoon, one set furnace kit with 5 kg cubical tongs, and then one unit aluminium rod, 1 inch times 1 inch, 24-inch, one driller, two sets nuts and bolts, and one unit 20 tons hydraulic jack, 5 bottles spray paint, and one hydraulic control box. So in this costing, we didn't insert the price for cast iron and steel, as this item we obtain it from the recycled item. So the total price for the making hydraulic filter is about 2,265.95. Note that in this quantity we take more than we needed because in case there is some damage during the process. That's all. Thank you.
Next, I will present on the usabilities of this filtration model. How does this press filter model work? The clay filter element is set in a clay receptacle which protects the filter element from damage and stores the purified water. One pours dirty contaminated water into the filter and the water filtered down through the tiny microscopic pores in the clay. The pore size is made larger with the additions of an organic burnt-up material, sawdust, rye husk, which allows the water to flow through at a rate of 2 to 3 liters an hour. Firstly, this filter press model works by using porous material which allow water to flow through while restricting the passage of potentially harmful microbes. It is capable of removing particles larger than the size of the pores in the clay material. Typically, bacteria, protozoa, and microbiologists are removed. And thirdly, the filters remove the bacteria includes E. coli and Vibrio cholera, as well as Giardia, Streptococcus, Total, coliforms, and Cytroporidium.
So regarding the practicality or the practicability, for this section we will be answering two main questions. The first one is why ceramic water filters and not any other type of filters? We can answer this in four main points. The first one is that the cost efficiency of this water filters manufacturing process, since it is so cheap to be made and also to be maintained. And also the ease of use, since this type of filters does not need a lot of training hours or experience to be familiar on how to use it. And also the simplicity of the design makes it able to be locally manufactured and also with available resources. And also the efficiency of this removing of bacteria process, and also, since it removes the E. coli bacteria and also the turbidity from water very effectively. The second question that we'll be answering is how sustainable is this kind of water filters? In regards to energy use, this type of water filters depends on hydraulic power, which makes it a good or a better option than any other type of filters. And also it uses recycled materials in the process of manufacturing this kind of filters. And it lasts long, like for 2 years and even more. And I think this is all from our presentation. Thank you, Dr.